Welcome back to our data engineering series. In this video, we'll discuss an essential pillar of data engineering, data storage and management. Let's start with a basic question. Why is data storage such a critical part of data engineering? Data is the foundation of modern decision making, but to be valuable, it must be stored in a way that ensures accessibility, security, and scalability. Poorly managed storage systems can lead to delays, inefficiencies, and even catastrophic data loss. There are several types of data storage systems, and choosing the right one depends on the specific needs of your organization. Let's explore some of the most common types. Relational databases. These use tables to store structured data and are ideal for transactional systems like banking. Examples include MySQL, PostgreSQL, and Oracle. Data warehouses. Designed for analytical queries, data warehouses like Amazon Redshift or Google BigQuery consolidate structured data for business intelligence and reporting. Data lakes. Unlike warehouses, data lakes store raw, unstructured, and semi-structured data. They are commonly used in big data scenarios. Tools like Azure Data Lake and AWS S3 are popular here. NoSQL Databases. These handle unstructured or semi-structured data with high scalability. MongoDB, Cassandra, and DynamoDB are examples. File systems. Sometimes, raw data is stored in distributed file systems like Hadoop HDFS, useful for large-scale processing. Each of these systems serves different purposes. For instance, a relational database might be perfect for storing financial transactions, while a data lake is better suited for collecting social media data or sensor readings. Let's move to the second key aspect, data organization. Storing data is just the beginning. It must also be structured in a way that ensures it's usable. Techniques like indexing, partitioning, and normalization optimize data retrieval and storage. Indexing creates shortcuts that speed up data retrieval. For example, creating an index on a customer ID column can drastically reduce query times for customer-specific data. Partitioning divides large data sets into smaller, manageable pieces, improving query performance and scalability. Normalization ensures that data redundancy is minimized, which reduces storage costs and maintains consistency. A well-organized storage system is critical for ensuring fast and efficient data retrieval. Next, let's touch on data management practices. Good management ensures the data remains secure, consistent, and available. Here are a few key considerations: backup and recovery. Regularly backing up data protects against accidental loss or corruption. Effective recovery mechanisms minimize downtime in case of failures. Access control, granting appropriate permissions, ensures that only authorized personnel can view or modify sensitive data. Data retention policies, defining how long data is stored, ensures compliance with regulations and optimizes storage costs. For instance, financial records might need to be kept for 7 years, while sensor data might only be retained for a month. To bring this concept to life, let's consider a streaming service like Netflix. They store vast amounts of structured data, such as user profiles, in relational databases, while unstructured data, like video files, goes into scalable cloud-based data lakes. Efficient storage and management allow Netflix to deliver personalized recommendations, ensure seamless streaming, and manage billions of records with ease. In conclusion, data storage and management are fundamental components of data engineering. By choosing the right systems, organizing data efficiently, and implementing robust management practices, organizations can unlock the full potential of their data. In our next video, we'll discuss data processing frameworks. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe for more insights into cutting-edge development tools. Meta Design Solutions is here to help. reach out to us at this email ID. See you in the next video.